Hi y'all, today we're learning about square roots, cube roots, and higher order roots. So let's start with some vocab. So you have your square root, which we have talked about in the past. It's actually called a radical sign. It's actually called a radical sign. So that's what that little dude is called. There might be a fancier name for it, but I don't know. And then you have your small number here, which traditionally we don't see because with square roots, we don't have them. But today we're going to learn that sometimes you have a little number right here, and that's called an index. It's like the size of a exponent, but it's inside the arm of the radical sign. And then finally, the number or the letters inside of your radical, that's called the radicand. We have this little note here. It says if there's no index, like if we had this square root sign, it's assumed that the index is 2, right? So it's assumed that it's a square root if there's nothing in there. So we have square roots that look like this, cube roots look like this, and fourth roots look like this. When we have square roots and we're simplifying, we're going to be looking for groups of 2. When we have cube roots, we're going to look for groups of 3. And we have fourth roots, we're going to look for groups of 4. So that index is really telling us, super important, it's telling us how many have to be in our group. So on today's assignment, you're going to see 3 levels. I'm going to go over one problem from each of them. We'll do 2 from level 1 here. So for level 1, we're going to start by breaking down the number. Right? What do I mean by breaking down? I mean, take the number and say, what multiplies to get 48? What are the factors of 48? You can use whichever ones you want. You can use 1 and 48, not that helpful. 2 and 24. You could use 3 and 16. You could use 4 and 12. 6 and 8. Let's do 6 and 8. I'm choosing those for now. You could choose whichever ones you want. It will all end up the same. 6 is 3 and 2. So I'm going to go ahead and cross out 6 because I multiplied 3 times 2 to get that 6. And then 8 is 2 times 4. The 8 is now gone. 4 is 2 times 2. That one is gone as well. So since this has no index, that means that our index is 2. So I'm looking for groups of 2, groups of like 2 of a kind. So I have 2 2s, I have 2 other 2s, and 3 is left over. So what I'm going to do is anything that's a group is going to go to the outside. So this group is on the outside. This group is on the outside. And any leftovers are going to go on the inside. So this 3 is staying on the inside. So sometimes I write it like this, like groups and then leftovers. Right, groups and leftovers. So now that I have my groups and my leftovers, I'm going to multiply together anything that is on the outside and then write anything that's on the inside here. This is the simplified version of the square root of 48. If you want to double check, you can absolutely use your calculator to do so. So I'm going to go ahead and find some clear space here. There we go. I'm going to go square root of 48 would be this decimal here. And I believe that that is the same as 4 times the square root of 3, which I see these decimals match, so I know that I did it correctly. This is how I would do a problem where I just have numbers like this. Go ahead and try this other one, and then pause the video, come back when you're ready. Cool. So I have to think of 2 things that multiply to get 72. I might know that it's 8 and 9. If I don't know that it's 8 and 9, that's okay. I can do 72 divided by any number and see if it works. So we'll try 3. Oh, so it's 3 and 24. I could have done 2 because it's an even number, 2 and 36. 4 works. 5 does not work because that is a decimal, right? So I don't want to include decimal numbers. I want to only use integers. 6 and 12. I like to use numbers that are easy for me to know what else multiplies into them. So I'll use 6 and 12 here. right? I know 6 is 3 and 2, and I know 12 is 6 and 2. I'm just crossing these out so I don't get mixed up. I've already created something else out of them, so I don't need them anymore. 6 again is 3 and 2. And now I have all prime numbers here, nothing that can be broken down further. So I know that my index is 2. So I'm looking for groups of 2 of a kind. So I have 3s, and I have 2s. That's another group. And then I have 1, 2 left over. It doesn't have a pair, so it has to stay inside its leftover. Right, so we have 3 times 2 would be 6. And then I have radical 2 left over. Double check my work here by saying, okay, square root of 72. Is that the same as 6 root 2? Yes, it is. Decimals match. So I know this is the simplified version. This is level 1, dealing with our square roots. We also have level 2 and level 3. The only difference is that our index is going to change, right? So how many we have to have is going to break it up. So we'll start with this one here. This 2 is a coefficient. I'm going to leave it alone for a moment. I need to break up 243. So 243, it is not an even number. So I'm not going to try 2. I'm going to try 3. Yeah, sweet. 3 and 81. Right. 81 I know is a square number. It's going to be 9 and 9. 9 is 3 and 3. And this 9 is 3 and 3. All right. So when I have a coefficient, my coefficient is going to come straight down. That number is already on the outside. I need groups of 3 because of this index. Groups of 3. 3 of a kind. 3 of a kind. So I have 1, 2, 3. So that's going to make a group of 3 on the outside. And then I have 1, 2. I don't have enough, so both of these are left over. They're going to stay on the inside. 3 times 3 on the inside, right? So I have 3 inside my radical. Then I'm going to multiply these together. 2 times 3 is 6. Cube root of 3 times 3 is 9. So this is my simplified version of what we started with here. This one's a little trickier in your calculator. You're going to type 2, and then you're going to go to this button here, functions. And then I'm going to look for the cube root. The cube root is right here. It has n inside in the index place. So I press n. You'll notice it'll let me type any number there. So I'm going to put a 3. And then in here, I'm going to put 243 equals 12.48. And then I'll go here and try 6 cube root of 9. I see that I have the same number, so I know that these are equivalent and I got the right answer. All right. All right, we're going to use a similar strategy here. This time we had an index of 3. This next time we have an index of 4. So I'm going to be looking for groups of 4, like 4 of a kind. Right? 4 of a kind. So 160 is 16 and 10. 16 is 4 and 4. 2 and 2. 2 and 2. These are all used up. 5 and 2 are here. 10 is used up. So I'm looking for 4 of a kind. 4 of a kind here. I have these 4 of a kind. That is a group on the outside. And then 5 and 2 don't have any friends. They're going to stay on the inside. 5 times 2. So 5 times 2 is 10. 4th root of 10 with that 2, that group of 2s on the outside. That is the simplified version of this one here. Okay. So those are our 4 examples. Feel free to ask any questions that you have. Don't forget your steps. Oh, we didn't finish them. We're going to break it down and we're going to look for groups. Break it down, look for groups, move the groups outside, keep the rest of them inside. Right? Don't forget groups on the outside, leftovers on the inside. All right. Thanks, y'all.